All right. So last week, first of all, thanks, Connie, for letting me take Thursday again. Today's class is gonna be kind of quick. We got a pretty busy day today, and but it should take us through the second section of the drain class. So we left off last week. Let me just get this started. So we left off last week. Let's see here. On dealing with stoppages and how we can access drains in a residential system. So our pre-diagnostics on how do we determine what's backed up. Is again, first look and see which fixture or fixtures is holding back water, running water, and other fixtures around that's backed up to see if it affects the fixture that's backed up already. Water rises, could be dealing with a lateral backup. If the water doesn't rise, we know that we're dealing with a fixture branch line before the lateral. So in this situation, we've done our diagnosis. We've ran the toilet. We've ran the shower. We ran the kitchen sink. We ran the lab sink, and nothing's affecting the tub that's got water in it. So let's talk about how we access the bathtub and the shower drain. So anytime we walk up to a backed up drain like this, for bathtub, is our access for this drain is going to be through the overflow, which is this plate right here. These two bolts come out, and this pulls right out, and that is your access to that drain. So what that looks like internally, just so that you guys can see, is that's where we take off our cover plate. This overflow plate, if some of you don't know, this is why your bathtub doesn't go over a certain height in water. Water gets up to this level and it kind of just spills over and goes down the drain, so it doesn't let the water go over the rim of the tub. But this is the access for the bathtub if you're going to snake it. So you snake it down through here, and this will take you straight into the trap. Quick overview on how this works. There's a trap over here. You pull it up and down, and these are the old style waste and overflows where this spring would push down on this lever right here, and it would close this drain here, and that's how it's able to stop the tub up and stuff. So sometimes when you're dealing with these, if you pull this out and you see these springs in there, I'd probably recommend you try and at least, if you can pull these, sometimes they're pop-ups, pull them out, because you'd probably end up tangling yourself on this lever here. But is the access, you're not going to snake the drain through here, you're going to snake it through the overflow.
What happens if you go from the tub?
So yeah, let's go back. If you go through the tub, this turn right here, you're never gonna get. You're not gonna know if you're going down, if you're going up, and then you end up potentially scarring this tub and breaking this. This is just a thin piece of metal right here. I mean, you risk busting that up, and then now you're dealing with, you know, a broken drain. But also, this is very thin. Also, this brass, sometimes it's plastic. Yeah, but it is not recommended to snake anything through here. I mean, I see people like use that plastic um thing you can get at like Ace or whatever, like customers have it, and they, you know, they push it through here to pull hair out or whatever. That stuff is kind of fine, but you're not gonna cable, you know, a drain through this access here. Did you want to explain anything else, Ken, on that? Ken? No? All right, I'm gonna move on. And then some of these overflows, they won't have this strep lower. They'll just be a cover plate like this. Again, it's just there to not let the water overflow the rim of the tub. Unless the drain is backed up, then yeah, it'll happen. So moving on, accessing a shower drain. So there's different types of shower drains. If we go back one, sorry. Hold on. These tub drains are, you know, the trap is 1.5 inches. And they are on the side wall of it's either going to be a left side or a right side tub, but they'll always be closest to the wall on an 1.5 inch drain. And then the shower drains usually come in at 2 inch. Well, they're supposed to be 2 inch. And these shower drains, the way you access these is if you look at this drain here, you notice there's no screws on here, you know, so the ones that you see without screws or anything, they're just a pop out kind of deal. So you just kind of get a flat screwdriver or whatever, and there's usually like a slot in there. You can just use it to pop the drain out. And then with this drain here on the right, you can see the screws holding on, the screws holding them down. Just take those screws out. That plate should come right off. Just be careful with some drains. They are plastic. But that is our access to shower drains. And then you can snake right down through there. Just so everybody can, knows what is, below the tub. Or so this is that overflow we looked at earlier. This is the plastic style. So it goes directly into a P trap and then into a vent tee or a sand tee, and then it drains out to the waste area. Similar to the shower. It's just the shower doesn't have an overflow on it. It's you glue the drain, right? You cut this to height, you glue that drain down directly into the trap and down into the sand. Sometimes people will and you can kind of just notice it when you walk into a bathroom. You notice it's 5 feet wide, and now they have a shower in there. Most original bathrooms, they've they're pre-installed with bathtubs, and then people don't need the tubs anymore. They want a nice shower, so they end up changing the tub to a shower. In a lot of cases, is remember the trap for a tub is 1.5 inches. So sometimes homeowners, they don't really hire the right people, or they try and do it there on their own, and they end up just tying in that shower to the old 1.5 inch P trap, which is not correct. Sometimes they'll have a 90, they have their shower drain, their 2 inch or 1.5 inch 90, and then they'll pipe it over to this old P trap that was in the ground here. And then, that makes it almost impossible to difficult to try and snake that shower drain. So be aware of all of that, there is showers out there that are still tied into 1.5 inch traps, which is not correct. And, you could run into some trouble with that. That is one thing to look out for when dealing with certain showers. Which takes us into a lavatory drain. We walk up into the restroom. We find the sinks backed up. So just to kind of see a cutout of what a pop-up assembly is, which is the drain for a lav sink, is it has the, it has the pull pin right here, which, activates the pop-up here. It locks into this here, and you go up and down. This apparatus will go up and down, but this is kind of a cutaway of what the inside of a pop-up looks like. You'd release this nut right here to pull this out. It's not showing that in here, and don't use this thing. I just wanted to show you a cutaway of what the pop was. And again, before the drain enters into the wall, it is an 1.5 inch trap directly into an 1.5 inch by 2 centi. The drain has to be 2 inch on a lavatory sink. So this is what underneath the sink will look like. We already went through the whole P-trap scenario. We just take these off, remove this trap, and our axis will be right in this drain going in the wall right after the trap arm. What it looks like behind the wall of a lav, like I said earlier, it's 1.5 inch trap, goes into an 1.5 inch T, or 1.5 inch by 2 inch drain. So this drain should be 2 inch, and an 1.5 inch vent. But that's just if anybody needed to know what's behind the wall of a lav. We'll walk into things like this, which is a side by side. They call it a his and hers lavatory sinks. And when I say lavatory, it is another term for your bathroom sink. Just like water closet is, toilet, it's just a plumbing term. So side by side sinks, I mean, just so everybody can, this is usually how it's plumbed behind the wall, is they come into one drain. Sometimes it'll be, this will be stubbed out to the sink, and then this one will reach over and dive in through there. So, always be aware of when dealing with, side by side sinks that, you do have the potential of skipping over, and, you're never going to get down this drain. But we're going to go through all that training with snaking after. I just wanted to show you kind of a rundown of what is behind the wall of most his and hers or side by side bathroom sinks. And they don't usually 90 like this out and through the forest. This is usually straight through the ground. But I just wanted to show you guys an example of what you could be dealing with. It's kind of good to kind of see this, so that when you walk up to things, you kind of already know what's happening or how you're going to deal with certain jobs. Accessing a kitchen drain. So we walked up to the kitchen sink now. Sink's backed up. Same way we're going to access this drain is through the 1.5 inch trap adapter here. This will all come off, and we'll snake it right through there. Kitchen sinks should have a clean out under it. It is code to have one installed on the drain of a kitchen sink. So always look for these two. Island venting. If nobody is familiar with an island vent, sometimes you'll walk into a kitchen. It's got this big counter in the middle of the whole kitchen, and they call that an island countertop. Or if there's a sink in it, it'd be called an island sink. So there is no walls around it. It's just it's like almost like a table sitting in the middle of the room with a sink plumbed into it. So just so that everybody understands how an island vent works, or an island drain, is that it's vented underneath the sink itself. So the drain goes through here, vent goes up, has to be, as high as you can get it up. It has to be, at least at the flood level height. So this vent is, it goes up, comes down, and let's just say this is all dirt down here. Sorry. So let's just say this is all dirt. This is concrete. This is what an island vent would be. It would look like. It comes up, vents down, then it's piped over to a wall to where it can be brought up out of the ground and through the ceiling. And that's also with the drain, comes down, ties in right after it. And of course, the vent also ties into this drain. But this is how an vent, like, if anybody was curious.
Josh, explain why the clean out is on the vent and not the drain. The
So
above ground, the
so
above ground
there
clean out.
shouldn't be any water in that that drain, but it is a better access. It'll take you straight into the drain. I mean, I don't know if I preferred it on the vent line.
So I think that the principle is in a backup, you're gonna fill up on an island, you're gonna fill up both the drain and the vent.
Right.
And that's so you can relieve the vent as well and the drain at the same time. Just so you don't, less chances of having a plugged up vent on a backup.
Yeah. So again, this is good to know right here because there are times guys walk into things and they're they get kind of confused on how this all works. But this is how an island vent looks. You don't usually get under the sink. It's usually in a little pony wall. But that's how the island vent works.
Can I ask a question, Josh?
Yep.
You see how that clean out is turned inside into the cat? Oh, so that's from the backside. Never mind. Sorry.
Yeah.
I
So we're
got
looking
that's
at
a
it from
rear
the back.
view.
Yeah.
Okay, never mind.
And the only reason why this clean out is down here is this is like an upstairs unit. This is not, I wouldn't put a clean out underground like this. This is probably like a second story. But moving on, other things to is we've all seen this right here. This is the dishwasher drain. It's tied into the disposal, or sometimes they'll have a little branch tee off the tailpiece. And the dishwasher drain, if nobody knows, this is what the dishwasher drain is also connected to, which is a dishwasher air gap. This separates the water from being in direct contact with the raw sewage, meaning the dishwasher water getting in contact with the raw sewage. If there's ever a backup, you have this air gap. The drain will never back up out of this. If this, if the kitchen drain line was backed up, it would fill up here before it even came out, this countertop, because the flood level is already here, so it's not going to reach up here. So the only way this would overflow is if you got a clog in the dishwasher hose. So that is the internals of how what an air gap looks like. It's, you have your dishwasher drain hose that comes up, it loops over, and between here and here there's no connection. It's just an indirect drain that flows straight into it. This is that that break of contamination. High loops are no longer allowed. For those of you who don't know what a high loop is they were allowing dishwasher hoses to be looped up as high as you could get it and back down into this, your connection to the disposal or stuff like this. Like that's the way I was doing it when we were in new construction, because a lot of people don't like that thing on their counter. It's just there. It doesn't have any use for them. But it is required by code now to have an air gap. But they used to just run this, drain hose up as high as they could get it in underneath the sink, loop it down, and tie into it. And this was their protection of contaminating your dishwasher water or whatever. If this backs up, you notice it in the sink before it even started backing up in your dishwasher. And it it doesn't have the opportunity to siphon back anything else that's going on in the drain. Any other comments, Ken?
No, good, thank you.
Okay. Moving on. So, like we talked about earlier, this is one of the codes in the book. Just domestic dishwashing machine. No domestic dishwashing machine shall be directly connected to a drainage system or food waste disposer without the use of an approved dishwasher air gap fitting on the discharge side of the dishwashing machine. Listed air gaps shall be installed with the flood level marking at or above the flood level of the sink and drain board, or whichever is higher. So this is this tells you straight away air gaps are required for a dishwasher drain. And again, this is coming out of our code book. Accessing a laundry drain. So we have all walked up to, hey, shh, quiet. We've all walked up to these boxes right here. This is what you'd call a washer box. You have your water supply, hot and cold, and then you have one port for your drain. Again, this is an inside look of what washer boxes usually look like when they're plumbed in. You have your tailpiece here, your trap goes straight into your sanitary or whatever, your vent line. So standpipe receptors, plumbing fixtures, or other receptors receiving the discharge of an indirect waste pipe shall be approved for the use proposed and shall be of such shape and capacity as to prevent splashing or flooding, and shall be located where they are readily accessible for inspection and cleaning. No standpipe receptor for clothes washer shall extend more than 30 inches or not less than 18 inches above its trap. No trap for a clothes washer standpipe receptor shall be installed below the floor, but shall be roughed in not less than 6 inches and not more than 18 inches above the floor. No indirect waste receptor shall be installed in a toilet room, closet, cupboard, or storeroom, or in a portion of the building not in general use by occupants thereof. Except standpipes for clothes washers shall be permitted to be installed in toilet and bathroom areas where the clothes washer is installed in the same room. So this is another code which kind of pertains to our washer drains. So no standpipe receptor for a clothes washer shall extend more than 30 inches or not less than 18 inches, which is what they're talking about. Let's go back to this picture real quick. They're talking about this right here. This is the standpipe. This shouldn't be more than 30 inches long and no less than 18 inches. So that they're talking about this arm right here. You know, they don't want it any shorter than 18 or any longer than 30 inches above its trap. So, and in no trap, clothes washer standpipe receptor shall be installed below the floor, but shall be roughed in not less than 6 inches. So they're talking about they don't want the washer trap underground, which is this right here. This is if this was concrete. They'd want it at least 6 inches above the floor level, no more than 18.
Can I make a comment?
Yep.
You guys understand why that would be? Why would you not want that P-trap underground? Let me choose Jacob. So just imagine you got a stoppage and you are trying to snake the drain. You got to open the wall. You got to get to the trap. What are you going to do?
And you're asking why it can't be put underground?
Yeah, I kind of gave you the answer.
Because you need to access it?
Yeah, I mean, it's pretty straightforward. So basically, you want that trap in the wall where you can cut it out so you can actually get into the drain. Does that make sense?
Makes sense.
So the code is stating, not to have it below grade. The new rough in. So when you guys are piping in a laundry box and doing the trap, what Josh was explaining was the trap arm is usually roughed in the wall. And then the tailpiece riser from the trap is no less than 18 inches and no more than 30. That's because of splashing. Like when a washing machine is dumping out water.
Yeah.
You don't want that thing hitting the trap and then splashing up and dumping over the top of that.
Yeah.
I'm not sure. The 30 inches, I'm going to assume because of
Siphoning.
there's a reason. What's that, Josh?
Siphoning. Yeah.
Okay, so siphoning.
It has the potential to siphon it so that trap out.
Can I say something though?
Of course, yes. Go ahead.
On a normal fixture, it's 24 inches max from a tailpiece coming from the P-trap. So it's interesting.
Right. Yeah.
It's 30.
Yeah. Well, the normal fixture is 1.5 inches on the drain size. This is a 2-inch. So a minimum of a washer drain is 2-inch. That's probably why it's allowed that extra length.
So when you say normal fixture, be specific. What are you saying?
Any tailpiece that comes from a P-trap can't be more than 24 inches. I don't know what code it is or anything, but I'm pretty sure that's true.
He's talking about like under a kitchen sink or shower drain.
Can I ask something? So why would a P-trap for a washing machine have to be accessible, but not say a washing machine or a shower, which is 2 inches as well, right?
Well, how would you make a shower accessible?
What do you
But
mean?
the drain's always going to be on the floor. Yeah.
Well, because a laundry has the opportunity to be accessible.
Yeah. That is the reason.
A shower is usually on grade. There's really no way around it. That's the one fixture that is kind of a situation where it is what it is.
I mean, if you think about it, like if you're like on the second floor, I mean, that is one way to access a shower drain. I mean, it is accessible, but it's always going to have to be below the floor because the shower drain is mounted on the floor. Yeah. Is that kind of what you're asking, Jeremiah?
No, I was just saying it was more of just a broad statement, just because, it was saying that, the washing machine, the P-trap has to be accessible, right? Which most fixtures are, lavatory, kitchen sink, all that. The P-traps are accessible. Only one that's not accessible is a shower. And obviously, for obvious reasons, it's on the floor level. But I mean, I don't know. I don't know if there was like just a book reason as to why it has to be accessible and a shower doesn't have to be.
I think it's
all logical.
Just practical, just for practical reason.
Okay.
Yeah, because in most cases, people can't snake through P-traps, so they make this. And laundry drains, any type of utility sink, kitchen, laundry sink, and even this laundry drain that's on its own, it should always have a clean out on it. They are required to have things. They don't require them on lavatory sinks and stuff like that. But any type of utility sink or where there's a lot of things going on, which is like a washer, a kitchen drain, it's required to have a clean out on the vertical side of the after the trap. But that is the rundown on a washer drain. So that's also one thing to get used to. If you guys ever get a call and you're like, oh, this thing's not, it's overflowing every time it's drains, try and just stick your tape measure down this drain, make sure it's no less than 18 and no more than 30. I tried looking like crazy through the book about if the laundry hose is allowed to be ran into a laundry tub, and I'm going to say yes, that it is okay to have it run into a laundry tub. They don't recommend it being running into a floor drain like this, but if you do see a laundry hose being looped over into a sink, it is all right to have because it is at the top of the sink, and so it is allowed. I couldn't find in the book anything that says it wasn't allowed. If you want a voice on that, Ken.
Yeah, I just think sometimes you'd assume that there should be an air gap where that potential of cross contamination may occur, or where you may have a water system dumping into a drain. But there's really no way to cross contaminate in a laundry. It's just the worst case scenario. It'll flood and maybe you get sewage from your laundry tub into your washing machine. Very similar to like a dishwasher, but there's no real way to put an air gap or anything on this application.
All right, moving on. So now we're walking into a backed up toilet drain. First thing, I mean, I was always trained never to have one of these stocked up in the van because we always got to assume that the customer's already tried this. I mean, you see these in every bathroom that there is. I mean, I wouldn't want to see a plumber walk into my house and just grab my plunger and, just start going at it with my toilet and clear it and be like, it's $100 job. So I would say not to use the plunger. That's a customer's tool. We have these things, which are augers, which is the more efficient way of clearing a backed up toilet. And here's a little bit of a cutaway of, what the auger is doing in the drain. I mean, it does have the potential to get down into the drain. If you guys have these rigid augers, they are extendable. I think it can go up to like 7 feet. If you look at the toilet trap, it's only about 2 feet, and then the rest of it is down the drain. Sometimes you do end up the vent or not getting down far enough, but if you're augering a toilet, I would say you give it about 5 to 6 tries. If you don't clear it, it's time to pull that thing. And
Can I ask you a question, Josh?
Yep, go ahead.
Why is that rubber part on the bottom of the auger?
Yeah, so I was just going to explain that. There's a reason for everything on these tools. Is if you don't place that rubber, and what Justin is talking about is right here. This rubber piece right here is made to protect that porcelain, because this snake will scar the toilet in this toilet, and it'll cause all these marks. And there's customers out there who really do they really do care about how it looks when they're looking down or whatever. But if they see all those scratches, just be prepared for a callback, and that's on yourself. When you retract these augers, you want to, this handle up here. Let me just zoom out real quick. This handle up here is you're going to pull it all the way out before you even get in the toilet. You're going to, fully extend your handle on your auger to where the tip is, right at the edge here of the rubber. And then you're going to place it in, just to get that, the tip of the snake in. Make sure your rubber is seated on the bottom of the bowl, and then you can start, going to town on trying to clear this with the auger. But even when pulling out, leave this thing sitting on the butt, because if you go and start, you pull your whole cable out, now the rubber is exposed, this whole cable is going to come out and it's going to scratch everything. It is a pet peeve for some people to not want to see scratches in their toilet. And some people think they score out of it because now they're like, I can get a brand new toilet. This guy scratched it. And it could be a 50-year-old toilet. So just be aware there's a reason for things. Keep that rubber down all the time until you're ready to, until you're retracted all the way back, and just pull it out slowly, because, it is a thing that, people have a problem with sometimes. Does that explain it, Justin? You good? All right. Moving on. And this is just a brief video of how, a toilet works.
The flushing toilet. How does a gentle push of a handle create a powerful torrent and refill the tank without overflowing? 42 components work together. A robust chrome-plated handle attaches to a solid brass lever. A set of intricately designed valves control water flow inside the 2-gallon tank. A large rubber plug tightly seals a wide flush hole. When the plug lifts, water shoots down in 2.5 seconds to flush away waste through an S-shaped bend. This remarkable machine leaves a shining clean bowl in 4 seconds flat. How does a machine with so few moving parts whip up a small storm? The secret lies in its carefully designed shape. In the largest ceramics factory in Ohio, skilled craftsmen hand-carved the prototype for the molds that give the toilet its distinctive shape.
The first one, it's all done by hand, and then after that, we have a mold to reproduce it.
Make one mistake with the shape of this crucial toilet bowl, and Dave will have to start from scratch.
We're trying to get the perfect shape for the perfect flush. Everybody in the world needs a toilet, so that's what we're trying to do. First one has to be done right in order for the thousands and thousands that follow it.
A streamlined body is just the start. To keep your bathroom clean and odor-free, toilets must remove waste quickly. So how do engineers create the ideal flush? It's all down to how the water is directed inside the toilet. The flapper valve unleashes water from the tank into a channel under the seat. 20% flows through specially cut holes in the rim to rinse the sides of the toilet. The rest shoots down a high-speed pipe, rushing through the bowl as a powerful flushing jet that can take care of any business.
So that brings us
Josh,
to
real quick, Josh, before you continue, on the scratching a bowl. If you guys ever scratch a bowl, don't go get a new toilet. Grab some sanding cloth out of your solder tray or steel wool if you have it, and just rub it out. It's not really a scratch. It's marring the porcelain. You think
Right.
it's a scratch, but you can rub it out and make it look brand new again.
Yeah, they
Just
even
wanted
have
to
like
throw that out.
they even have like a scoring stick, which is a pumice stone that you can rub down there, and it takes those scratches out. But just kind of be aware of what you're doing, and this is what the whole training is about. But that is one way to try and get those marks out. So again, this brings us back to it brings us to the end of our second section of this drain class, which is our residential plumbing. I haven't been talking about snakes. That's all going to come up later. I just wanted to talk about what we run into in in residential homes, each fixture, how to gain access to each fixture, what's each fixture pertaining, how their drains look. I tried to give you guys like an x-ray vision of what to kind of what you're gonna see or how you can deal with certain things. That way it's always good to have that inner vision of what's happening, because you already know, because some people are sticking these snakes in the walls and they don't know what's behind that wall, or what they could be potentially dealing with. So I hope this helps with all of that stuff. But we are 7:50. I didn't think it was going to go this long today, but we do have a very busy day ahead of us. And I'd like to thank everybody for being here today. Thank you, Connie, for letting me take over the Thursday again. And everybody have a great day.
Thank you, Josh.
Thank you, Josh. That's good.
You're welcome.
Thank
Thank
you.
you guys. All right.
Thank you, bye, Josh.
Thank you.
Roger.